Welcome to Module 5, Lesson 7. This lesson is going to take a relatively short amount of time because I have kind of mentioned everything this lesson in prior lessons just to kind of help prepare this idea, because I feel it is hard to teach this without the other concept kind of simultaneously. Now we're going to hit on that other concept that I'm just about to tell you here in a second, to kind of really cement it in. So, what are we talking about today? And that is, I can identify and represent shaded and non-shaded fractions as one whole. As mentioned before in earlier lessons, you can look at this in two different ways. You can look at it as just a shaded. And first off, well, fraction-wise, you have your numerator and your denominator. The numerator's on top, the denominator's on the bottom because D down, so denominator. So how many pieces does it make to make a whole here? 4. And so I'm going to put 4 in both of them. Over here is your shaded blocks. Over here is your unshaded blocks. How many of the blocks are shaded? 1. So I'm going to go ahead and put a 1 right there. How many blocks are not shaded? 1, 2, 3. 3. So the idea behind here is that this entire thing is one whole. I have 1 of those 4 pieces that's shaded, and I have 3 of those pieces that are not shaded. So if I put these pieces together, I would have a total of 4 pieces out of 4. And 4 out of 4 is 1 whole, which equals 1. And as a reminder on this, this division sign is just, or this is just a division sign. 1 divided by 4, 3 divided by 4, 4 divided by 4. So if I have a total of 4 and I'm skip counting by 4, how many times do I count? 4. 1 time. So that's why it equals 1, because you're having 4 and you're putting them all into one group. Basic idea that we've kind of talked about so far. So this doesn't just work with 4 here. I can go ahead and give you another example here. And once again, the entire idea that we're trying to grasping at right now is the idea that the unshaded and the shaded, they both play a part in recognizing what this is. Because if you have an entire piece of cake, if you cut that cake into 5 pieces and you eat 2 of those pieces, well, there's still some cake left over. Just because you took 2/5 of that cake doesn't mean the remaining 3/5 just disappear. That's not how it works. So you could also say, like, maybe you have a long donut, one of those like long donuts with like caramel on top. If you've ever been to a football game, specifically here in Utah, at BYU, they call them cougar tails. Those very long pastries with like the caramel drizzle on top. They're very good. But let's say you had to share that with your family. And let's say you had 6 people in your family. So what I'm going to do is I'm going to make this into 6 equal parts. For the purposes, we're saying these are equal to the same. And let's say you and your 2 siblings eat your share. So you ate this piece, maybe your brother ate that one, and then your baby sister ate that one. Your older sister, she didn't want one right now. She's like, I'll save mine for later. And your mom or dad were too busy watching the game or doing something else, and they weren't able to finish theirs. So for this one, I could say that the black shaded parts are how many you've eaten, or how many of this pastry you have eaten. And you have eaten how many pieces? 1, 2, 3. How many pieces of what? How many total do we have? How many does it take to make a whole? 1, 2, 3, 4, 5, 6. So 3/6. And then, since you're not allowed to eat your siblings or your parents, you kind of stick the remaining back into the bag, roll it up so that they can eat it later. So how many pieces were not eaten? 1, 2, 3. Got 3 pieces there. And how many pieces total were there to make a whole? 6. So I would hope that if you had 6 pieces and you ate 3 of those pieces and you had 3 left over, assuming you actually, let's say this, you split this up into 6 pieces and you took 3 because you were going to eat them all. And your parents were like, oh, no, we got to share them. Give them all back. I'm assuming the 3 that you took, if you brought them back, you'd still have a whole, right? It's kind of going off of that idea. Once again, going to a cake. If you had 5 pieces of cake, you had a cake cut into 5 equal pieces. If you took 2 pieces away, sat down, looked at it, and went, you know what? I'm not hungry. And you went back and you put the cake back onto the tin or the plate that the rest of the cake is on. There's not going to be more there, and there's not going to be less. It's going to equal 1 cake. That would be pretty cool, though. You take 2 pieces of 5, and then you come back. You have more cake than when you originally had. Unfortunately, the world that we live in, that's not how it works. It'll be cool, but that's not how it works. What you take away plus what you left should equal 1 whole. It's kind of like if you have a sandwich for lunch, if you only eat half of that sandwich and you zip up the remaining and you put in your like your lunch pail and you took it home, when you open up that pail, there's not going to be a fourth of a sandwich there or a full sandwich in there. It's going to be what's left. It's going to be half of that sandwich. So once again, 3 pieces plus 3 pieces equals 6 pieces out of 6, which would equal 1 whole piece. Once again, this entire lesson's idea is, even though you have stuff taken away in a fraction, there's stuff left. Or, if there's stuff left, how much was taken away? That's the idea here. A better visualization of this could potentially just be viewing this as a subtraction problem. Let's say you have let's do a pie. A big pie here. And it is cut into 8 pieces. So, in total, you have 8 pieces of 8, right? Has any of those pieces been eaten yet? No. So how many pieces do you have? You have 8. How many pieces of pie does it take to make a whole pie? 8. So you have 8 pieces of 8. Now, let's say you and your family during Thanksgiving dinner ate 6 of these pieces. So you eat 1, 2, 3, 4, 5, 6. My question to you would be, what fraction, not how many pieces, what fraction of this pie is still there? And, well, how many are left? 1, 2 of 8. So you have 2/8 of your pie left. Now, it's important to realize this number down here, doesn't change in addition or subtraction. Why? Well, your whole is staying there. You still have a whole. If you have 8 pieces to make a pie, taking away a piece or 2 isn't going to change the whole. It still takes 8 pieces to make that whole. Just kind of keep that in mind there. But overall, view it this way. 2 separate things. You can find out what fraction is there, what fraction is not there. So this is 6/8 is shaded with 2/8 not shaded. So that's kind of the entire lesson, is just recognizing there are 2 parts to this, to a fraction. The one that you have and the one that you technically don't have. So just kind of keep that in mind. Hopefully this was helpful, and I hope you all have a great day.